Hello guys, this video is made for our assignment CSM 256. So, our chosen topic is volumetric analysis direct titration in wine industry. Before we start, it would be nice if we introduce ourselves. First thing first, my name is Muhammad Zikullah bin Fikri.
Hi, my name is Ian Roshan Tila.
Hello everyone, this is Abu Zar.
Without further ado, let's begin with the introduction. I will explain you guys about what is volumetric analysis. Volumetric analysis is any method of quantitative chemical analysis in which the amount of a substance is determined by measuring the volume that it occupies. Meanwhile, for titration is a technique where it's a chemical qualitative analysis technique that is used to calculate the concentration of a given analyte in a mixture. Titration is an important technique in the field of analytical chemistry and is also referred to as volumetric analysis. Besides, for direct titration, a direct titration is a direct addition of standard titrant to analyte in the presence of acid-base indicator until the reaction is complete and reach the equivalent point. You guys must wondering, what is titration in the wine industry for? I will tell you guys about it and you guys don't worry. And it is to control the pH, sulfur level and overall acidity of the wine. Meanwhile, for titration is very important in winemaking. This is because it to maintain the quality and the content of wine. In addition, it's also to determine the quantity of specific constituent in mobile phase. Next, there's 4 types of volumetric analysis and I will tell you guys and with example of each. First thing first, we have acid base, which is the basic types of volumetric analysis and the example of it is determination of percent of acetic acid in vinegar. The second, we have complexometric. Example of it is water hardness. Water hardness is determination of calcium and magnesium. The third one, we have precipitation. The example of it is determination of chloride in water. The last type is redox. An example of it is quantification of hydrogen peroxide.
So moving along, the next one is the theory of titration. Titration is a quantitative analytical technique used to determine the concentration of an unknown analyte, usually as dissolved substances, in a given sample. It involves adding a solution of known concentration, that is titrant, to the sample until the reaction between the analyte and titrant is complete and a measurable change occurs. The process of titration involves incrementally adding the titrant to the sample while monitoring the change, for example, the pH, color, conductivity, and etc., until the endpoint is reached. The volume of the titrant required to reach the endpoint is then used to calculate the concentration of the analyte in the sample using the stoichiometric relationship between the reactants. There's also a key component of the theory of titration, which is the first one, equivalence of point. The point at which the amount of titrant added is chemically equivalent to the amount of analyte present in the sample. The second one, endpoint. The point at which a measurable change occurs in the solution, indicating that the reaction is complete. The third one, indicator. A substance added to the sample solution that undergoes a noticeable color change at a near the equivalence point. The fourth one, stoichiometry. The balanced chemical equation of the reaction between the analyte and titrant determines the mole-to-mole ratio between them. And the last one is titrant concentration. The concentration of the titrant is known accurately either by direct standardization or through primary standard substances.
Moving on, we would want to discuss the methodology for wine titration. The materials needed are 0.1 mole NaOH solution, phenolphthalein indicator, wine sample, 25 ml Bouret, 10 ml pipette, distilled water, 100 milliliters beaker, conical flask, retort clamp, and a retort stand. The procedure for this experiment would need to be the application of the Bouret into the retort clamp and the retort stand to then add 0.1 mole NaOH up until it reaches the 0 mark of the Bouret. Afterwards, we take the conical flask and add distilled water into it for about 100 milliliters of the distilled water. Moving on from this, we would pipette about 10 milliliters of wine sample into the distilled water, which then we would afterwards add the phenolphthalein indicator into the wine sample. The phenolphthalein indicator should be added at least 2 or 3 drops. Next, we want to start our titration, where the endpoint that we are trying to expect should be a constant pale pink. As our expected result, we want to see a clear to light pink result. Remember that the lighter the result is, the more accurate the sample is. The examples of results are as shown, and that is it for the methodology.
I'm going to discuss about the advantages and disadvantages of volumetric analysis in direct titration in wine industry. First one is accuracy. For the advantages, direct titration is known for its high level accuracy when performed correctly. Properly standardized titrants and precise measurement can lead to reliable results. For the second one is precision. With carefully execution and repetition of the titration, direct titration can yield precise and consistent results. For the third one is rapid analysis. In many cases, direct titration can provide quick results, allowing for timely decision making during the wine making process. For the last one of the advantages is cost effective. Cost effective is equipment and reagents for direct titration and generally affordable, contributing to its cost effectiveness for routine analysis in the wine industry. Alright, that's all about the advantages, and let's move on to the disadvantages. For the first one is interference. Wine is a complex matrix containing various compounds that can interfere with the titration reaction. Selecting suitable indicators and titrants to account the potential interference can be challenging. For the second one is skill dependent. Despite its simplicity, direct titration requires skilled personnel to perform accurately. And third one is endpoint detection. In some cases, in direct titration, detecting the endpoint of the titration accurately can be challenging, especially when dealing with the fan color change and complex matrix. For the last one of the disadvantages is sample volume requirements. Direct titration may consume a relatively large volume of wine sample, which could be a concern for limited or valuable samples. Alright, to end up our presentation, in summary, volumetric analysis using direct titration is a vital technique in the wine industry, enabling accurate measurement of acidity, sulfite content, and residual sugars. This method ensures wine consistency, stability, and safety. It has been widely adopted to its cost effectiveness and simplicity, benefiting both small and large scale of wine producers. However, analysts must be cautious of potential interference in complex wine matrices. Overall, in conclusion, direct titration has revolutionized in the industry, providing valuable insight into wine composition and quality, contributing to continuous improvement in product and quality control process.
Oh yeah, so before we ending our presentations, here is our reference that is the source that make our presentation possible.
Alright, thank you. That's all from me.
Thank you for watching.
Thank you.
I think that's all from us, and I want to say thank you for all of you guys that watching our videos. Okay, bye.